Good evening, everyone. Hope all are doing good. So, yeah, today we have our trainer Umar. So, Umar, you can take up the class.
Okay, Chandana, I'll just start in some time.
Umar, your voice is not audible.
Yeah, I'll just start in 2 minutes.
No, it's not.
I'm audible now? Am I audible now?
Sorry, Umar, it's not audible. If
Not audible? Am I audible now, guys?
Yeah, you're audible for me.
Okay, let's start in a minute now.
Yes, Umar, you are audible. You can speak now.
Yes, Chandana, let's wait for everyone to join. We have a headcount of around 300 plus. So let's take 2 minutes for everyone to join and then we'll start. Hi guys, am I audible?
Yes, you're audible.
So let's continue from where we had left yesterday, right? So yesterday We had finished with string, okay? And I give us some examples, right? So let me open up my Eclipse screen for you all. People are still joining in. Let's wait for everyone to join. Interview preparation batch. Okay. So this is what we did yesterday. And we had done a string demo, and I gave you an overview of what is string constant pool, right? Everyone's comfortable with string constant pool now? Okay. So one more thing which I wanted to discuss today regarding strings was mutable and immutable property of Java. Okay. Also very common question asked in the interview. Mutable and immutable property of Java. Okay. Mutable and immutable property of Java. Now, what is mutable property and what is immutable property? Okay. Now, what do we mean by the term mutable? Mutable means which changes its state, right? So the COVID virus was mutable. It would constantly keep on changing its state. So they would make a vaccine for a particular variant, and then after a few weeks, it would change. So it would mutate. Okay. So it constantly keeps on changing. We will call mutable, and which doesn't change. Once it is defined, it will not change. So doesn't change, that we call as immutable. Okay. So here string is immutable, guys. Always remember, string in Java is immutable. The string of Java is immutable. Once I create the string, it cannot be modified. Now, what I mean by it cannot be modified? Yes. So let me take a real world example and explain it to you all what I mean by. So if let's say this is a apartment and it's a 1-bedroom hall kitchen, 1 BHK. Okay, and it is in some expensive area. Okay, it is some expensive area of a city. So the rates will be high in this area. So if in the house we have some furniture, there's some showpiece in the drawing room, some cabinet in the bedroom, something in the kitchen. So these all furniture is there. Now, if they want, so the son was small, so 1 BHK was sufficient for the family. Now the son has become old, become young, and now he is supposed to get married. So 1 BHK is less for the society, for the family. So now they want a 2-bedroom. So can they expand this apartment here itself? Not possible, right? So if you're staying in an apartment, in a flat, you cannot do any modification in the flat. There is no room for modification. So what will they do now is, so let's say this expensive area, let's say if I talk talk about Pune, let's say this is Koregaon Park. Okay, we have an area called as Koregaon Park. So what they will do is they will sell off this flat of Koregaon Park. So 1 bedroom for Koregaon Park will fetch them, let's say, 60 lakhs. And they'll purchase a 2 bedroom in some outskirts of the city, because there is no room for adding a room over here. So with this 60 lakhs, they can purchase a bigger flat, a 2 BHK at somewhere far from the city. So on the far from the city, they can purchase a 2 BHK, right? So let's say this is in Kharadi. Okay, this is, let's say, a far off area. So there in 60 lakhs, they can easily get a 2 bedroom. So this Koregaon Park flat was immutable. Any changes at that flat was not possible. If ever there was to be make any changes, then all this furniture they will carry to the new flat now. So in the new flat, they'll carry this furniture, and whatever new furniture is to be added, they'll add it over there in the new flat. So for the next bedroom, they need some wardrobe, some furniture. So extra thing which needs to be added will be added to the new flat. There they cannot make any changes. So strings by default is immutable. Once I define a string, changes in the string at that very location is not possible. If I need to make any changes in the string, I have to go to a new location and then make the changes. Okay, so let me, yeah, new object will be created at a new address. Okay, so let me come here and let's follow the same pattern. So I go to SRC, right click, I make a new package, day5. Okay, and in this we'll make a class called as immutable demo. Immutable demo, and I add main to it. Finish. Okay, and now what do I do? Okay, now let's try to make a string. Let's try to make a string. Am I audible, guys? Okay, so if I make a string first name, if I make a string first name, and if I say Alice, okay, so string first name is Alice. So now let's try to draw it also. So we are doing immutable, right? So now I have Alice as my 1 BHK apartment at address 1000. At address 1000. At address 1000. And who's pointing to it? It is being pointed by the string name. It is being pointed by the string name only. So where is name pointing to? 1000. What is that? 1000 Alice. So if I come here and display sys out first name, it should show me Alice. But now if I concatenate anything to Alice, if I say first name dot concat, and if I say space Fernandez, okay, and then I say this is my new first name, or I can say full name. If I say, okay, just let me do the same reference. Let me use the same reference. So if I do now first name dot concat, and if I concat Fernandez, so Alice becomes Alice Fernandez. So does the Fernandez get added at address 1000? Tell me. Does the Fernandez gets added at 1000? What do you all say? String is immutable. No. So Sonia. No. Because string is immutable. Whatever changes happens now, what happens is now a new at a new address, let's say 2000, this Alice will be copied, and whatever needs to be concatenated to Alice, whatever extra needs to be added, will be added at this new address 2000. And here it will be pointed by the, so if the first name was pointing over here, if the first name was pointing over here, now this first name reference will point over here. And now this will be garbage. This will be garbage.
Hello.
Yes, yes, one second. I'll be back. Yes, guys. Am I audible? Hello?
Yes, you're audible for us.
Yeah. So there's some festival going on below my house. So that is some noise or the disturbance was there. I was just closing the windows, but still there is some noise. So what happens over here is now, I'm audible, right, to you all guys?
Yes, you're right.
Yeah, so whatever now modification will take, that will take at a new address 2000. Okay, so now this 1000 address, now there is no reference pointing over here. So the memory location to which no reference is pointing, that is marked as garbage. That is marked as garbage, and the garbage collector will automatically revoke this memory. So Java is a automatic garbage collected language. Java is a automatic garbage collected language. So whichever reference it will see that there is no, whichever address it will check to which no reference is pointing, so that that address is marked as garbage, and the garbage collector will automatically free up this memory. Okay, so there is a garbage collector in Java. So as a programmer, we just need to take care of allocation of memory. Deallocation of memory will be taken care by the garbage collector. The garbage collector is always in search of those memory addresses. Garbage collector is in search of those memory addresses to which no reference is pointing. So reference is pointing to 2000, but there is no active reference pointing to 1000. So this will be marked as garbage.
Hello, are you there?
Chandana. Chandana. Hello.
Yes, Uma.
Yeah, this Ganesh festival celebration going on below my building. So that's why
Okay.
there's disturbance. I'm trying to go in some peaceful place where I can take this session. Am I audible now?
Yeah, you're audible for us.
Yeah. So that's why I was moving from one place to another.
Okay.
Do you
Yeah.
all hear some
Take
back?
it.
Do you all hear some disturbance in the background?
No, actually, it's you're clearly audible for us.
Perfectly audible, right?
Yeah, perfectly.
Okay. Let's. Okay, guys. So this alteration will not take place at the same. It will take place at a new address, and I have shifted the reference now. The reference was pointing to 1000, now is pointing to 2000. So as there is no active reference pointing to 1000, 1000 is now garbage and will be garbage collected. And now whenever I display first name, will display me Alice Fernandez. Okay. Am I audible, guys?
Yes, you are clearly audible.
Okay. So now let's go to the programming and check. So now if I display sysout first name, so now it will display me. First it will display me Alice, and then I have moved the reference to Alice Fernandez, that is to a new address. So if I now display, it will display me Alice and now Alice Fernandez. But this Alice Fernandez has not happened at the same location, it has happened at a new location. Because once I make a string, that string is now becomes immutable. It becomes immutable. You cannot modify that string. So if whatever modification happens will happen at a new address. Okay. So at any time when I modify this string, always a new address will be generated. So now if I add something else to this Alice Fernandez, some new string, that Miss Alice Fernandez, then this will again be at a new address, not at the current location. This will again be at a new address. So every time I add something to the string, a new address will be generated and the old address will become garbage if there is no reference pointing to it. If a reference is pointing to it, then it's fine. See, if I would have done this, so this is first name, and if I would have done, if I would have done this, if I would have done this, string full name, then what would happen? So what would happen now? There is still a reference which is pointing to 1000 because I have not deleted. So the first name is pointing to 1000. And when I have added Fernandez, I made a new reference called full name. So now full name will point to 2000 and first name will point to 1000. And now still now there is an active reference over here. So this is not garbage. This can be accessed later on. So now if I display full name, I can also display the first name. So if I display first name, it will display me Alice. And if I first name dot concat Fernandez goes into reference full name, if I display full name, it will display me Alice Fernandez. So now I can refer both the strings. See, so I've displayed it twice. I can cut this off. See, so first name also is being displayed and full name also is being displayed. Okay. Now you all try this, guys, and see how it's working on your machine. Who's doing parallel programming with me? Who was doing parallel programming with me? Yes, Dipit. Yeah, come on. So try to write this code. Okay, and this is immutable, right? And mutable is string buffer. So if you want to use mutable, so for that we have, okay. So if I say mutable demo and I add this, so mutable means, so what I mean by mutable is, what I mean by mutable property of Java is the changes take place at the very same place. It will not check, it will not go to a new address. So if there's a farmer and he has a large field and in one corner of the field is his house. Now this house was one room. Now his son has become, young enough to get married. So he will just make one more room besides this house. So at the very same address, the changes are happening. So that is called as mutable. So the house, so if some guest came last year, he would say the house was one bedroom. When he comes after 1 year, he will see the same house has become 2 bedroom. So changes has happened at the very same place. So if I take a string buffer, and string buffer, you cannot use the buffer literal. You have to make the object. You have to make the object. So if I say first name equals to new string buffer, okay, Alice. So now what happens is Alice will get memory from 1000. So at address 1000, I have Alice. At address 1000, I will have Alice. Now I can just do append. So if I say first name dot append, and if I add Fernandez to it at the very same location, the Fernandez gets added. It will not go at a new address because string buffer is mutable. The changes takes place at the very same place. So try this, guys. Okay, be with me and try this. Okay. Yeah. So try to port this and see how it is working. So I want you all to make a string first name, then to that add the middle name, and then to that add the surname. So do this using string also, and do the same using string buffer also. First do it using string. Okay, do this. Guys, I'll be back in around 2-3 minutes. Okay, I'll practice this. Yes, guys, I'm back. So I hope you all are getting the hang of it. So what is mutable and what is immutable? Okay. So string is immutable. Whatever changes will happen at a new address. The current address will not be modified. That is immutable. And string buffer is mutable. At the very same address, we can make the changes. Okay. So when would I use string buffer? So if I tell you all that there is a file, if I tell you there is a file and that file has some data, okay, some text file it is some notepad textual file, and you have minimize, maximize, and close keys. So this is some file, and this file has some information in it. Okay, let's say the file has information full stack developer. This is the content in the file. Now I want to read this content of the file into my application character by character. Okay, so I make a variable called file data and I initialize it with blank. Initially I make it blank. Then I copy one character at a time and add it over here. So if it from double, before it was blank, then it becomes F. Okay, then it becomes FU. Then it becomes FUL. Then it becomes FULL. Then it becomes FULLS, like this, blah, blah, blah. So what would be ideal in this scenario to use? Should I use string buffer or should I use string? And what would be the advantage and disadvantage of not using the other? So if you are saying you should use string buffer, so what will be the advantage of string buffer? What? So what should we use over here? String or string buffer in this use case? See, if I use string in this use case, F will come at 1000. Then as this address cannot be modified, whatever changes will be made at the next address. So at 2000, I will have FU. Then I cannot add L at this address. So the address will be at 3000. So like this, it will become very slow. Because at each iteration, I need to copy the data. So copy the old data, keep on adding it. So add and moving to different addresses will slow down the application. So this would be a good example of using string buffer. Yeah, memory will be wasted. So this will be a good example to use string buffer. So at 1000 I have F. At 1000 only I will have F. At that very address, I will have FULL stack. So at the very same address, all the data is being added. So these memory address will not be wasted, and my application will become faster by using string buffer. So if you have a lot of modification activities, then you should go with string buffer. And if you just want to store some data, like your password, if I make a password, I will not keep on modifying this very frequently. So then you can use your string for such use cases. And this data will not be modified. It's immutable now. So better we use for such credentials. For storing user credentials, we will always use string. And to play with the data, we'll use string buffer. Okay. Let's go to the next question. So this was there over here. Okay. So we have string buffer, and string builder does the same task more or less. Now we have next topic. What is an array? Okay, this also is very commonly asked. What is an array, guys? Who can tell me? What is an array? Two important things. Whenever you are explaining array, you need to, whenever you are explaining array, two things you have to bear in mind and explain. So whenever you're teaching array, You need to say two things very important. First is it is continuous memory allocation. And second is homogeneous type. So array is allotted. Array is a collection of homogeneous elements with the same. Yeah, that is what is the meaning of homogeneous, Arun. Homogeneous itself means same data type. So if you're writing homogeneous, then you can skip the same data type because homogeneous itself means same data type. So everybody is telling me homogeneous type, but the most important feature of Java is continuous memory allocation. So continuous memory allocation for homogeneous type of data. So I can store multiple data in sequence using an array like this. But array is homogeneous, okay? Homogeneous means same type. So if there's a match going on between India and Australia, so in the Indian team dressing room, you will see all players wearing blue jersey. Will you see any player of yellow jersey sitting in the Indian team dressing room? No. So they all are of the same team. So similarly, if I make an array of integer, these all values will be integer, irrespective of whatever value it is, but they will be of only type integer. So 10, 20, 30, 40, 50. Okay. And the array has indexes. So the first index of the array is starting from 0. The last index will be size of the array minus 1. So what is the size of this array? The size of this array is 5. How many elements is that an array storing? That is called as the size. We call that as length in Java. In Java, we call that as a length. Keyword is there. So what is the length of this array? Length of the array is the number of elements stored in the array. So how many elements are stored in this array? 5 elements. So the length of this array is 5. Okay, so this length of this array is 5. So, and the starting index will be 0 and ending index will be starting index will be 0 and ending index will be 4. Okay. So how do I declare the array now? Okay, so when I declare an array, there will be, and every array has a base address. The address of the first element in the array is the base address of that array. Okay, so now I will write an array has multiple dimensions. We'll discuss that also. So now if I write this sentence, integer ARR of size 5, okay, and this is my ARR of size 5, okay. This is my that ARR of array. This is my that array. So now I will put 7 pointers, and you all should tell me what are these 7 pointers. If you're studying array, you should know these 7 things. Okay, so if anybody has got the answer, can send it across on the chat. What are these 7 things? Tell me. So one, okay. Let me give you a minute. Take a minute and send me these 7 things. What are these 7 things? Okay, let's see what I have sent. So one is data type. Okay. 6 is the data in the array. Okay, value. 7 is the base address. Okay, perfect. This is right. One Bhavya. Okay, 1 is data type. Perfect. 2 is the variable name, array name. Perfect. 3, 3 braces. Braces is the dimension of the array. Always remember. So 1 is the data type of the array. Means this array will store data of this type only. So this array will only store integers. Okay. If I try to store a decimal or floating point number in this array, it will not accept. Correct? It will not accept. So if I try to store 50.5, it will throw me an error that you cannot store a decimal in an int array. So 1 is the data type. 2 is the name of the array. Okay. What array we have given? So name of the array. 2 is the array name. Then what is 3? 3 is the dimension of the array. We can have array in multiple dimensions, 2D array, 3D array. So how many pairs of square brackets are there? This is called one pair. This is called one pair. So how many pairs of square brackets are there, guys, over here? How many pairs of square brackets do you see? How many pairs? How many pairs of square bracket do we see? One pair. So one pair means this array is one dimensional. So the number of pair, those many dimensions you can think of. So this is one pair. So it's a 1D array. So this is a 1D array. If I would have added 2 pairs, if I would have written this, if I would have written this instead, integer ARR of 5, 5. Now, how many pairs of square brackets over here? 2 pairs. So this would be a 2D array. So this is a 1 pair means 1D array. Now what is the fourth part? Fourth part is the length of the array or the size of the array, whatever you call it, whatever you wish to call it. If you call it length or you wish to call it size of the array. Okay. I would rather prefer length. Okay. In Java, I would rather prefer length. Then 5 is the indexes of the array. Index is starting from 0 and index ending at size minus 1, length minus 1. So length is 5, the last index will be 4. 6 are the values of the array, okay, what you actually store, values. And 7th is a base address. So if you can explain an array with these 7 points, you have covered the entire concept of array. Okay, theoretical, we are good to go. Now let's do some programming. So if I come here, so today is day 5. Make a new class and say array demo, and I finish this. Okay. So let's try to make a array. So integer ARR. So now I can give hard-coded values. If you want to declare an array and initialize at the same time, you can do so like this. You can give any number. Okay, I'm just giving random numbers. Okay, you can give any number, any order. This is my array. And now if you want to now do some operation on the array, let's say I want to find the sum of elements. Okay, this we had done on the first day, I guess, when you were doing looping, and I had discussed for each loop, right? We had done for each loop. Matrix will be done in 2D array, Arun. 2D array, rows and columns. Base address is the starting of the array is called as the base address. From okay, Shrikant, the index of the first element in the array is called as the base address. So when arrays are non-primitives, so they are passed by their address. So I need the address of the arrays. What is the address of the array? The address of the array is the address of the base element. Now this array is an integer type. What is the size of integer in Java? We had done on the very first day. One integer is of 4 bytes, right? 32 bits we had seen. So what would be the address of the next number then? 1000 plus 4. So how much? 1004. Because one array stores how many bytes? 4 bytes. So if I get the base address, I can calculate the address of any index. So next address will be on 1008. Then 1012, like this. So I just need to know the base address of that array. And arrays are passed by, called by reference. So you pass the base address of that array. So now if I have this array and now I wish to, let's say, calculate the sum of this array. So how would we do that? So we would take a sum equals to 0. We would take a for loop. And if I want to iterate to the indexes, I will say integer I starting on the index 0 going till index 5. So how do I write 5? What is the length of this array? 5. So I can directly just say ARR dot length and I plus plus. Now what is the value of I in the first iteration? You should know what is the value of I and what is the value of ARR of I. So these two things you all should be able to differentiate. What is the value of I and what is the value of ARR of I? So in the first iteration, value of I is 0 and ARR of I is 10. So what do I need to add to the sum? I need to add 0 or I need to add 10. I want the sum of elements of the array. So I will take sum, I will say sum equals to sum plus ARR of I, not I. So what will be the value of sum in the first iteration? So I'll have a variable called sum also, which is initialized to 0. So the first iteration, sum plus ARR of I, 0 plus 10 is 10. 10 will go in which variable? 10 will go in sum. So my sum becomes 10. And then I plus plus, I becomes 1. And is 1 less than 5? Yes, come inside. Sum plus, what is in sum? 10. What is of error of I? I value is 1. What is error of 1? Error of 1 is 20. So 10 plus 20 is 30. So on and so forth. Your iterations will go, and at the last you will have the, so now when you have I becomes 2, error of 2 is 30, 30 plus 30 is 60, 30 plus, okay. So now error of I is 40, 30 plus 40 becomes 70, what happened? 10, 20, 30, 0 plus 10, 10, 10 plus 20, 30, 30 plus 30 becomes 60, 60 plus 40 becomes 100, and 100 plus 50 becomes, so now it becomes 4, it becomes 50, okay. Your 10, so sum was 0, 0 plus 10, 10, 10 plus 20, 30, 30 plus 30, 60, 60 plus 40, 100, and 100 plus 150 becomes 150. And when my I becomes 5, my loop will break, because this 5 less than 5, no. And when the loop breaks, I will come out and I will sys out and I will display the sum. So like this, once you have the array, you can iterate through the array and do the tasks. This should print me 150. Okay, the same we had done using for each loop also, if you all remember. The same task we had done using for each loop. Okay. Same we had done using for each. How did we do that? Who recollects for each? So we don't have to play around with the indexes that much. We just take the array and put a for loop. In each iteration, one element from the array will come in the n. In each iteration, one element from the array will come in n. Now, what is in n in the first iteration? 10. And I will add sum to, so I can write sum is sum plus n, or I can write sum is plus equal to n. Okay, now the code becomes much more cleaner. And once the loop terminates, I can display the sum. Sum declare the sum. So this will become even more faster. Okay, so this is how your 1D array works. So now if I give you a task, okay, if you all remember, we had done the mod 10 and divide by 10, correct? So if I ask you all, accept a number from user and check whether it is Armstrong or not, how will we check that? I don't think so. There is an enhanced for loop in C, Shivam. This is Java, we have enhanced for loop. I don't know there is an enhanced for loop in C. C has a traditional for loop. Okay. Now if I give you all a task, okay, now these elements I had hard coded them. If I want to accept from the user, then what to do? If I want to accept these elements from the user, so I can just declare, okay, I'll just comment out everything. If I want to accept value from the user, I can make a new array. It is a BRR. And this is how you make an array in Java like this. So int BRR, this shows it's an array, and here you have to give the size of the array. Now a blank array of size 5 has been made, and now I want to insert 5 numbers in it. So I take my scanner variable. And now how many numbers will I ask the user to enter? 5 numbers. So I'll take a for loop which will run 5 times. So simply I will just say I equal to 0, I less than BRR dot length, and I plus plus. And I will ask user enter a number. So this message will be printed 5 times, and each time he enters a number. So let's say he enters 10. I want to put 10 at which index? 0 index. 0 is with I. So declare the I. Okay, let's declare the I over here. So what will I do now? I will say BRR of I will be SC dot next int. So if you enter 10, 10 will go at which index of BRR? I index. I is 0. Next iteration I becomes 1. Like this. 5, 10 it will ask me, and the 5 numbers will go over there. And if I want some of those elements now, I can do it like this. If I want some of those elements, I can take one more element and put it to BRR. I have not declared sum, declare sum, and initialize is to 0. So now if I run this code, it will run and it will ask me to enter the final number. I can enter any random numbers. Okay. So let me enter 45, 18, 63, 93, 12, and this is the total. Okay. Yes, Arun. If you want to take the size of the array from the user, if you now I have given this hard coded size of 5, right? If you want to take the size of the array from the user, so what you can do is, okay, so let's make a new class so that we can, this code doesn't get messed up. Okay, user defined length array of user defined length. Okay, so if I want to take the length from the user, what I can do is I can take a scanner first. And then I can sys out enter length of array. So whatever length user enters, I take the length variable or size variable, whatever variable name you want to give, equals to sc dot next int. And then now I can make the array of that size. Okay, of what? Of size. Okay, so now how many elements I need to accept from the user? Size and size numbers. So then we can directly take this. This code we can take now and put it. User I and the array name is CRR, right? Wherever we can make it BRR because now we are in the same different class. So see here, I have accepted the size of the array. I made the array of that size. Now that is the length of this array. And now we can find the sum of the elements of that array. So if I hit over here, if I enter 3, and if I enter 45, 15, and 10, directly will show me the length of the, it will only accept 3 elements. Okay. So, getting it, guys? Now we can declare our own array. So we had done the mod 10 divide by 10 program yesterday. So can you now accept a number from user and check whether that number is Armstrong or not? Can you accept a number from user and check whether it is Armstrong or not? What is an Armstrong number? An Armstrong number is one whose, yes, An Armstrong number is a number whose cube of individual summation of cubes of individual digits form the very number. What did I say? Whose summation of cubes of individual digits form the same number, form the very number itself. Okay, so this is the Armstrong rule. So if I take for example 153, what are the individual digits of 153? 1, 5, and 3, correct? So 1, 5, and 3. Now take the cubes of these individual digits. Take the cubes of these individual digits. What is one cube? 1 into 1, which is 1. Take the cube of 5, which is 5 into 5, which is 125. And take the cube of 3, which is 3 into 3, which is 27. Now add these together, what do you get? Now add these together, 1 plus 125 plus 27. It will give you the very number itself, which is 153. So if I ask you all, accept a number from user and check whether it is Armstrong or not. Come on, let's do it. 125 is not Armstrong. Between 1 to 1000, we have 4 to 5 Armstrong numbers. Anushka, we can check this out. Do we have Armstrong numbers in 4-digit also or 5-digit also? 370 is also Armstrong. 371 also is Armstrong. 407 also is Armstrong. So between 1 to 1000, we have quite 5 to 5 numbers. I guess we have Armstrong. Then we can increase and check if there are any Armstrong numbers between 1 to 1 lakh, 1 to 10 lakh. So do we have any 4-digit Armstrong number, 5-digit Armstrong number? That we can verify. So right now my question to you all is accept a number from user and check whether it is Armstrong or not. Come on. I give you 2 minutes to code and then you all send me the answer. Yes, guys, come on. We will check that out, Rutik. If there is any 4-digit Armstrong number, we'll check that out. Okay, so let's try and figure out. Let's make a class called Armstrong number. I add name to it, finish it. Take a scanner. System.in. Okay. So let's take a number from user. Okay. We've got the number sc dot next int. Okay. Now, how do I check whether it is Armstrong or not? The same logic which we had done for sum of digits, same to same logic. There, if we will have adding the number, here we will add the cube. While n is greater than 0, we'll take the integer r. Okay, and we also take the sum. Initialize sum equal to 0. So what will we do? R equals to n. Mod with 10, I get the last digit. Then in the sum, instead of adding the number only, what do I add? I add the cube of that number. Instead of adding the number, we add the cube. And then n is n divided by 10. Okay, now if you observe over here, the number has now become 0. So I need to compare it with something. So once I take the number, I put it into a backup. So my backup also has that same number. And then I will compare with the, so if my backup is same as my sum, then I will sys out number is Armstrong. Okay, so let me save this. Right click, run as Java application. So if I enter 153, it will say number is Armstrong. And if I enter 123, it will say number is, it won't say anything. Okay, so I did not put a else over here. I should have put a else over here. number is not Armstrong. So this is a simple program. 123 will be not Armstrong. 133. So then the next Armstrong number is 407 is Armstrong. 370 is Armstrong. 371 is Armstrong. So now, can you all print me the Armstrong numbers between 1 to 1000? So now what we did is we took one number and checked whether it is Armstrong or not. So now if I ask you all to Armstrong numbers between 1 to 1000. So how will we do that? So now I will not accept the number from user. So see, the same logic which I've applied over here, I'll apply. Just check this out. Okay, so I want you all to do pair programming with me. If you have not understand anything, please ask me. Now I am not accepting a number from user. So now my n will come from where? My n will come from a for loop. We start from 1, we'll go till 1000 and plus plus. So I start from the for loop from here. Okay. So now my n is not coming from the user. It's starting from 1 going till 1000. And whatever number I have in the n, I'll take in the backup. Okay. So let's not fidget with the n over here. Okay. So I'll take, okay, let's take over here number. Number equals to 1. Number equals to 1000 and number plus plus. And take that number into n. So in the first iteration, what is the value of n? 1. We are checking whether 1 is Armstrong or not. And now where's the backup? Backup is in n. So but now I'll compare it directly with the number because the n has become 0. And I will display that number, right? So I'll directly display the number. And we will not use any else over here. And we can just put a sys out Armstrong numbers between 1 to 1000. Okay. Now see, we are running a for loop. So in my first iteration, what is the value of number? Number value is 1. So whichever is the value of number, I'll take in a temporary variable n. So my n also will be now 1. Whatever comes in number is in n. Now I will first check I'll find the sum of the digits of n. Okay, so here I will get the sum as 1 only. The only single number is there. So here after the loop finishes, my sum will have value 1. I will have value 1. Now I will compare all. Now n has become 0 because when the loop will terminate, n will become 0. So I need to compare my sum with what? Number. So I compare my sum and number. If they both are same, I display the number. So I display 1. So 1 is Armstrong. Like this, when I increase the loop and my loop becomes 153, let's say. It becomes, let's directly fast forward to the iteration 153. So what is in number? 153. 153 will come into n. 153 will come into n. Sum will become 0 for everyone. Sum is 0. So what are we calculating? While n is greater than 0, keep on calculating. So is n greater than 0? Yes. So what it will do now? 153 greater than 0. Find r. What will be in r then? What will be in r? The first iteration? R will be 3. Then 3 into 3 into 3, 27. 27 plus 0 is 27. Will go in sum. Sum becomes 27. And n becomes 1, 5. Look, goes back. Is 1, 5 greater than 0? Yes. R goes, what comes in R? R comes 5. Earlier R had 3. So now what is 5 into 5 into 5? 125 plus sum is 27. Sum becomes 152. Sum becomes 152. And n becomes 1. Loop will go up. Is 1 greater than 0? Yes. Find the last digit of 1. Last digit of 1 is 1. Sum plus 1 into 1 into 1. That is 153. So your sum becomes 153. And your n becomes 0. N becomes 0. This loop will terminate. Now what do I compare the sum with? I compare the sum with the number. If they both are same, I display the number. I display 153. So like this, it will display me all the Armstrong numbers between 1 to 1000. Here you get. So these are 5 numbers between Armstrong number between 1 to 1000. So now we were discussing, are there any 4-digit numbers? So if I go to 10,000 and check, are there any? There are no 4-digit numbers Armstrong. Let's check, are there any 5-digit numbers Armstrong? So I save and I run. There are no 5-digit numbers also Armstrong. Are there any 6-digit Armstrong numbers? Check it out. Save and run. There are no 6-digit Armstrong number. The biggest Armstrong number is 407. Okay. Someone had an issue, no? What is the biggest Armstrong number? Do we have Armstrong numbers in 5 digits? No. Biggest Armstrong number is? Yes, Anushka. 4-digit Armstrong numbers, are there anyone? Which are there? Which is a 4-digit Armstrong number? There aren't any 4-digit Armstrong number because when I ran the loop, 1634, is it Armstrong? Is 1634 Armstrong? Are you sure? I don't think so. What is 4 cube? 4 into 4 into 4 is 4 into 4 into 4 is 64. Okay. So let's try to see 1634. Is it Armstrong or not? We have the question right over here. Let's run and check. Let's run and check. So 1634 is not an Armstrong number. 164 is not Armstrong number. Let's try run it. Let's dry run it. Okay. Let me open Excel. Let's dry run in Excel. 1634 is the number you told, right? Okay, you all wanted the cube. Okay, we'll take the cube also. No worries. First, let's check the number which she gave, 1634. Okay, 1634. So what are the individual cubes? Individual digits? 4, 3, 6, and 1. What is 4 cube, guys? 4 cube is 4 into 4 into 4. That is 64. What is 3 cube, guys? 3 cube is 3 into 3 into 3. That is 27. What is 6 cube, guys? 6 into 6 into 6. That is 216. And what is 1 cube, guys? 1. So if I add these together, it gives me 308. How come it's showing you on Google that 1634 is Armstrong, ma'am? Okay, so if it's a 4-digit number, then power is to 4. Is that what you're telling? Okay, then let's multiply it with 4 once again. And let's multiply this with 3 again. And let's multiply this with 6 again. Yeah, okay. That is the case, then yes. Okay, power raises to 4. Okay, okay, okay. Okay, then his power is to 4. Yeah, okay, okay. Okay, so the number raised to the cube means if the number is of size 3, then cube. If size 4, then 4. And then if size 5, 5. Okay. That is the logic behind Armstrong. Okay. Not always cube, depending on the size of the number. Okay. So if it's a two-digit number, then if it's a two-digit number, then square, right? 3 square and 2 square. What is 3 square? 3 square is 9 and 2 square is, so 13. Then you're trying to say 13 is Armstrong then? No, the 3 square is 9 and 1 square is 1. So that will become 10. So 10 is an Armstrong then. 10 is an Armstrong number then. No, 1 is an Armstrong number. 10 is not Armstrong. Okay, there is no two-digit Armstrong number. There is no two-digit Armstrong number. Okay, good one, guys. So now if I tell you all that except 5 numbers, okay, except 5 three-digit numbers now, except 5 three-digit numbers, and tell me which are Armstrong and which are not Armstrong. So if you accept the 5 three-digit number as 123, 153, 120, 370, and 455, whatever. So accept 3-digit, 5 numbers of 3-digit, and from here tell me which are Armstrong from these. So what will the output be? The output will be 123 is not Armstrong, 153 is Armstrong, 120 is not Armstrong, 370 is Armstrong, and 455 is Armstrong. So how will we do this now? So now for this we'll require an array. We'll store these 5 numbers into an array and then iterate through an array, correct? — 154 is not Armstrong. 3 is Armstrong means, what is 3 is Armstrong? As it is a single digit number means raised to 1. So any single digit number is Armstrong then by this definition. Even 4 raised to 1 is 4 and 5 raised to 1 is 5. Okay, we'll restrict our discussion to 3-digit numbers. Come on. So your array is of this type now. This is your array. Now tell me if I store these numbers. Okay, I can any random 3-digit number I will take, and I want you all to tell me each digit whether it's Armstrong or not Armstrong. So how will we do this? Come on. So for this we will require the definition of array over here. Okay, so we'll be using array. So I'll make a new class, array Armstrong. Add main to it. Okay, array Armstrong. So let's declare an array of size 5. So this number we have done over here. Array of user defined size, array demo. Okay, let's make a new one. Array Armstrong. So let's make an array of size 5. So I have told you all size 5, right? And now accept and store value in this array. How will we do that? For that, we will do like this. Run the for loop and store it into the array. Run the for loop and store it within the array. Let's keep the array name BR. So, and let's take an integer I. So, and we don't have a scanner. Let's take a scanner also. Let's take a scan. So now I have got these 5 numbers stored in the array. What are the 5 numbers? 5 numbers were these. These 5 numbers I have in the array. So which index is 123 at? 123 that index 0, 153 at index 1. So that index 2, at 3, and index 4. Yes. So now I need to check for each index whether it is Armstrong or not. So again, take this loop and I'll initialize the sum equal to 0 over here. So I'll declare the sum over here. I'll initialize it equal to 0 inside the for. That for each number, the sum becomes 0. Now what will I do? Take the number into the n. So take each number from the array and put into n. So what is in n now? Now in n I have the first number. And now check whether this is Armstrong or not. So will I check it? While and I need the sum. Initialize the sum to 0. So while my n is greater than 0, come inside and do what? We need a R also. Declare them over here. So my R will be n mod with 10. Sum will be sum plus R cube and n equals to 10 divided by 10. Now my sum and my BR of I will compare. Because n has become 0. So I'll say if my sum is equal to BR of I, then I will display that element. Is Armstrong. And if it is not, then I will say BR of I is not Armstrong. Okay, so let's save this and let's run it. Okay, so I will say what? Enter 5 3-digit number. Okay, enter a 3-digit number. So we are focusing on 3-digit numbers, right? So I save it, right click, run a Java application. So 123, 153, 120, 370, 455. So 123 is not Armstrong, 153 is Armstrong, 120 is not Armstrong, 370 is Armstrong, and 455 is not Armstrong. The same concept we have applied on the array also. Now guys, are you able to see my Eclipse screen? Okay, my Excel was visible on this file. Okay. So see, what I did is I took an array of size 5 because I had told except 5 numbers. Okay. And then I accepted the 5 numbers and I have thought of entering these 5 numbers. I have put it over here. Now I take this sum n and r. For Armstrong, I'll be needing them. Then again for each number I want to check. So I start my I with 0, as 0 is my first index. 0 is my first index of the array. So I start the loop from 0 and go to the length of the array. It is less than 5. Okay. Then I take one number and put into n. So in each iteration, now what is in n? N is 123 now. Now we have done how to calculate a single number Armstrong. So that logic we have applied over here. So check. So n, I will keep on adding and taking the sum of the cubes of n. So 3 cube plus 2 cube plus 1 cube. So will become 8 plus 27 plus 8. That is 35. 35 plus 1, 36. So my sum will become 36. When the loop will break, sum is 36. I will compare 36 with AR of I. Are they same? Is 36 equal to 123? If yes, say the number is Armstrong. If no, number is not Armstrong. 36 is not equal to 123. So we'll go into 123 is not Armstrong. I'll freeze the screen for y'all. Y'all can try programming on it. Okay, so let me fit the entire stuff on one line for you guys. So let me copy this and put in a notepad file for y'all so that y'all can have the entire code in one frame and y'all can practice. I would appreciate pair programming, guys. As I'm programming, do programming with me so that y'all don't lag behind. Okay, see this. Okay. So let me push all this code onto the GitHub repo and share all the GitHub repo link also. So today's work I'll push onto the. So let me push today's work also. Today is day 5, right? Okay, so now you can do this code and check if it's working for you. Yes, guys, I am able to code. Anybody has got the output? I have pushed the code on the GitHub, guys. So if you just refresh the link, the same link, I guess you'll have the GitHub link. I'll refresh it once. This is the GitHub repo. This is the GitHub repo. And the link for the attendance also has been shared in the chat at around 8:30. The link was shared. If you'll scroll up for the 8:30 timeline, you will see the link for the attendance also. You can just mark your attendance over there. Now, not able to download the class session means, so again, the link has been shared for the attendance. Not able to download the class session mean on the GitHub you are trying to say? GitHub, you have the entire session code for the all the sessions. See, I'll share my screen. See, day 2, day 3, day 4, day 5, all sessions are over here, guys. If you want to go to any particular day, let's say you want to go to day 4 on the GitHub repo. See over here the link which I shared. The link which I shared on the GitHub. You can just hit that link. You will see all the day 2, day 3, day 4, day 5 work. If you want to see yesterday's work, click on day 4 and you will see all the Java codes over here. Right, you will see it. And mark your attendance also. Yeah, it won't open on the phone. GitHub, I guess you will require a laptop or just a website. So you will better access it via a laptop. Anybody who's written the code and is getting an output or any error or want to share the code, then we can troubleshoot it. See, these are all programming sessions, right? So I want you all also to code with me parallelly. Okay, so you all should also get into the hang of writing the code. Mission, you try to log in from a laptop and then try to hit that link. You will be able to see all the and download all the documents. If it is not opening from the mobile, it should open using the laptop. We don't, there's no provision of copying in this chat. So if I had the provision of copying from the chat, I would have surely shared it on YouTube. Let me ask the coordinator if he or she is able to send it across on YouTube. I don't know if there is any provision of sharing the link on YouTube. Saloni, is there any provision that we can share the link to this candidate on YouTube? How will we share it?
For GitHub link, right?
No, no, the attendance they're asking, I guess.
Yeah, attendance already shared actually.
Already share, right? Yeah, attendance
Yeah.
link is asking. Vaishnavi is asking, can you send attendance link on YouTube? They didn't post it on YouTube, she's trying to say. Gulshan, what you can do is you can just hit this link which I shared on of over here. See, this GitHub link which I have shared over here. You just open it. When you click this link, it will route you to the GitHub page, and there you will see all the tasks. I'm sending it across to everyone again. So just you need to do is click on this link, and my GitHub page will open, and you have all the folders over here of day-wise programs. You can choose any program, any task, any program which you want to check. So if you want to check today's work, you click on day 5 and you will see all the program which I have done today. See. Okay. So if it is not opening on the mobile, try logging it. Login next time, logging from a laptop. Join the meeting from a laptop. Okay, guys, then I guess we're done for the day. I'll see you all on Monday at the same time. Okay. Anyone have any question, any queries, any concerns? Okay, then have a nice weekend. Bye, guys. Sonali, I'll jump off. You'll take over. Okay, then I'll jump.
Yeah, sure.
You can take over. Bye, guys. Take care.
So guys, I'm going to share attendance link. Please mark your attendance. Once you mark attendance, please let me know. Put it in the chat box. Yes, Gulshan, actually you can go through the YouTube, no? Yes, Varsha, I'm sharing up. Yes, Penny, thank you. Which link, Gulshan? Yeah, till 9:30 actually, Areen. Yes, Ashri, you can leave.